Hi, this is Mike at Farming Smarter here, just giving you a quick update on what we've been up to here in the fall and how things are going for some of our hemp trials. Hemp is grown for 4 potential end uses: feed, fiber, food, and fractions. In our research at Farming Smarter, we're mostly concerned with the fiber and the food, which translates into measuring things like the plant density, biomass weight, male-female ratio, and the grain yield of the hemp plants that grow out in our fields. In the field, we start by measuring 1-meter rows and then harvesting the hemp a few inches above the ground, simulating where the equipment might cut it or where an animal might graze it in other instances. We usually harvest 2 to 4 rows in the front and again in the back, depending on the size of the plot, the crop, and the end use of the data we're collecting. That usually amounts to 1 to 2 meters squared, or 10 to 20% of the plot, depending on the size. In some cases, we're able to leverage some learnings and hands-on experiences with Lethbridge College students who come to learn about the hemp agronomy and get some hands-on experience cutting research samples and then using the data for their class assignments. In this example, we'll cut 4 by 1 meter rows and then sample the weeds in between as well. The reason for this is that the weed biomass helps us quantify the efficacy of the herbicide treatments from earlier on in the season and gives additional backup to any observational and efficacy data that we may have taken. The hemp samples are then processed for fiber and grain yield as well. We'll often take wet and dry weights in order to calculate the moisture of the samples as well. Here I'm taking the weight of a dried hemp bundle from a plot. We tare the weight of any bags, bindings, or tags that may be on the sample and make sure the sample's only touching the scale as not to skew the results. For hemp, we can quite aggressively bang the seed from the rest of the plant and get a separate weight from the fiber and grain. In other crops or other instances, we may just put the sample through a stationary threshing machine or something along those lines. Here I'm putting some sample through the seed cleaner to get a more accurate measurement of the grain yield. We can do this in lieu of or compare to the yield from our plot combine, being mindful to subtract the area we removed in the biomass from our plot area in the final yield. This cleaner uses an adjustable airflow and rotor speed to separate the particles based on the size, the shape, and the weight. The lighter fractions are blown further along the tube to the furthest collection chamber, while the seed falls down to the closest collection chamber. If the sample isn't clean enough, we can adjust it by turning down the speed of the rotor or increasing the speed of the wind. So this has been a sneak peek of some of the behind-the-scenes work that happens here at Farming Smarter, and be sure to stay tuned for some new and exciting things upcoming on the horizon.